Assalamualaikum and good day. I will continue lecture for chapter 3, voltage drop, part 1B. Okay, this is the outline for voltage drop, part 1B. Okay, we'll cover transformer, voltage drop. Okay, this one, voltage drop, transformer, and voltage drop due to motor starting. Okay, next is the transformer voltage drop. Okay, previous lecture video, I have explained about the cable voltage drop. So, I will continue with transformer voltage drop. Okay, for voltage drop of transformer, the formula is by using approximation method. Okay, this one. This is the formula. Okay, voltage drop is equal to ILS, okay, times use RTR cos theta minus XTR sin theta. So, after we get the voltage drop, we have to calculate what is the percentage of the voltage drop, which is equal to V drop divided by VLS times with 100%. Okay, first we have to calculate what is the RTR, XTR. Okay, three-phase transformer impedance. Okay, reflects to the low voltage side. So this is the RTR and XTR. Okay, that reflect to the low voltage side. So percentage of R times with secondary line voltage power of 2 divided by transformer volt amp rating. So same goes to XTR, okay, by using this formula. Okay, if given in percentage ZTR and XR ratio, so we can get the value of theta by using this formula. Theta is equal to tangent inverse X divided by R. And to get the percentage of RTR is equal to Z, percentage of Z times with the cos theta. And to get the X percentage is equal to Z times with sin theta. Okay, so we go to example 4. Okay. Determine the voltage drop through a 115 kVA 3300415Y volt 3-phase transformer having an impedance of 4% and SR ratio is 1.8. The transformer is operating at full load 0.82 lagging power factor. Okay, this is the solution for example 4. Okay, first step. Okay, first we have to find what is the theta. So theta by using this equation. Theta is equal to tangent inverse X divided by R. So X per R is given in the example, which is 1.8. So we just put all the value in the formula. So theta is equal to tangent inverse 1.8, which is equal to 60.95. Okay, second step, we have to find what is the value of percentage R transformer and percentage of X transformer. Okay, by using this formula. Okay, this formula. So, okay, this formula. So, we already know what is the Z. Okay, Z, percentage of Z is given in the example. Okay, which is 4%. And we have already know what is the theta. So, put all the value in this formula and we can get the value of R, TR and XTR. Okay. Okay, the third step, we have to calculate what is the RTR and XTR by using this formula. So put all the value in the formula and we get the RTR. This one is RTR in ohm and this one is XTR in ohm. Okay, next step number 4, we have to calculate what is the full load current of the transformer if not given in the questions. So ILS is equal to S divided by square root 3 divided by 415 angle inverse cos power factor. Okay, this one is power factor value which is equal to this value. So this one is theta. Okay, and then step number 5, put all the value in the voltage drop formula. So this one. So we can get what is the voltage drop. So this one is R. Okay, this one is theta. This one is R. This one is X value. And this one is theta. So we get the value of voltage drop is 8.61 volt. Okay, after that, last step, we have to calculate what is the percentage of voltage drop. Okay, it's equal to V drop divided by V system. So this system is 3 phase, so we put 415 value. So the percentage of voltage drop is equal to 2.07%. Okay, next, last part for part 1 is voltage drop due to motor starting. Okay, voltage drop or voltage dip occurs due to large motor starting. Okay, because of the starting. Okay, the voltage drop is large when starting large motor applied to the system having a relative high source impedance. Okay, and then there are 2 common methods to determine the voltage drop due to motor starting, which is constant impedance and constant current. Okay, next we go to example 5. A 50 horsepower 415 induction motor is to be started with full voltage applied from a 415 step down to 240 volt. Okay, system whose equivalent impedance is 0.01 plus J 0.02 ohm per phase. Okay, assume a log rotor power factor is 35% lagging and the log rotor kVA per horsepower is 6.3. Calculate the percentage of voltage drop, okay, during starting using A, constant impedance, and B is constant current representation. So there are 2 conditions. The first one is constant impedance and the second one is constant current. Okay, this is the solution for example number 5. Okay, first we have to calculate what is the value of kVA. Okay, in the questions given 50 horsepower, so we have to time with 6.3 kVA horsepower. So we get the kVA for log rotor. And then the second step, we have to find what is the I log rotor, which is equal to S, this one is S divided by square root 3 divided by 415, and we get this value. And third step, okay, we have to find what is the P and Q. Okay, P is equal to IV cos theta, as we know. So it's equal to S times with power factor. So we get this value. So S is equal to IV sin theta, okay, which is equal to S times with sin theta. So we get this value. Okay, next, step number 4, we have to calculate what is the log rotor R and X. Okay, we get the value from this formula. P is equal to 3I power of 2R. Okay, this one is the formula for power motor, power at motor for 3-phase. Okay, to get the R, which is equal to P divided by I power of 2 divided by 3, which is times with 1/3. So we get this value. Okay, same goes to X. Q is equal to 3 power of 2I power of 2 X. So to get the X, which is equal to Q divided by I power of 2 times with 1/3. So we get the value of X. Okay, then step number 5. Okay, we have to calculate what is the voltage at motor terminal. So by using a voltage divider rules, okay, so we put V, okay, V M is equal to Zm divided by Zm plus Z system times with V. Okay, so we put all the value here. Zm we already get from step number 4. Okay, and then Vs 0.01 plus J 0.02 is given in the example. Okay, so after put all the value, we can get what is the voltage at motor terminal. This value. Okay, okay, and then for step number 6, final step, we have to calculate what is the percentage of voltage drop, which is equal to V system divided by V voltage drop divided by 240 times 100, which is equal 3.91. Okay, sorry, for voltage drop we have to minus. Okay, V system minus with Vm, so this one is V system minus with Vm, and then divide by V system times with 100, and we get the what is the value of voltage drop. Okay, next we go to solution example number 5 for B, which is constant current. Okay, so we get the Im from the previous solution, and by using voltage drop using approximation method, we can get what is the value of voltage drop for constant current. So this is the formula. We just put all the value. This one is Im. Okay, this one is R. L refer to the R system given in the example, and then this one is theta. Okay, from this value, and then we get minus with X. This one 0.02 is given in the example sin theta, and then we get the value of voltage drop. Okay, and then lastly we have to calculate what is the percentage of voltage drop. Okay, which is equal to 4.05. Okay, next is the voltage drop due to motor starting by using approximation. Okay, in some case, the load rotor power factor cos theta of the motor may not be known. So in this case, it is possible to have an approximation value of voltage drop due to motor starting by assuming that the voltage drop is in phase with the source voltage. So for previous example, we can get V drop is equal to I, okay, times with Z system. So I times with Z, which is given in the questions, which is 9.8. And then percentage of voltage drop is equal to V drop divided by V system times with 100%, which is equal to 4.08. Okay, next we go to example 6. Single phase. This one for single phase. Okay, determine the voltage drop at service panel for system below. The total load is 8 kVA at 0.85 lagging power factor. So for this system, we can see here, this is the transformer. Okay, this is the value of transformer. Okay, and connect to the service entrance panel with 3/0 AWG aluminium PVC conduit 120 feet cable. So this is the cable connected to the service entrance panel. So this one is the service entrance panel with load of 8 kVA, 0.85 power factor lagging. Okay, this is the solution for example number 6. Okay, step 1, determine all system impedance. So we have transformer, cable and also load. So for transformer, okay, by using this formula, we can get what is the impedance. Okay, so we already know what is the RTR percentage and XTR percentage. If not given in the questions, we have to calculate the percentage of RTR and XTR by using this formula. Okay, and then we get the value of R and X value of the transformer. And then we go to cable or wire. Okay, I already explained how to get the RL and XL, okay, for cable in part 1A. Okay, for this example, we know that this is the single phase. So, single phase voltage drop consider the load current flowing from the source to the load and back to the source. Okay, this is the condition for single phase. That's why to get the RL and XL, we have to times with 2 because there are two-way. Okay, this value is from the table. Okay, and this value also from the table. Okay. Okay, next step 2, determine load supply at the end of each segment or portion of the system. Okay, already given in the questions. Okay, the loading is 8 kVA at 0.85 power factor lagging. And then step 3, we have to determine the load current magnitude and phase angle. Okay, so from the load, we can get what is the value of I. Okay, by using this formula, so we get the value of I here. Okay, next is step number 4. We have to calculate what is the percentage of voltage drop along each segment of the circuit starting at source. So we have two segment, which is transformer and also cable. Okay, the first one is transformer. By using approximation formula, we can calculate what is the voltage drop. Okay, put all the I. This one is I. Okay, this one is RTR. This one is theta, cos theta. Okay, theta. And then this one is X. This one is theta. Okay, and then finally we have to calculate what is the percentage of voltage drop for transformer. We get 0.62%. And then we calculate for cable or wire by using voltage drop approximation formula, same as transformer. We can get what is the percentage of voltage drop for cable. Okay, final step 5. Okay, add the voltage percentage of voltage drop along each segment starting at the source to the point of interest. Okay, add here. Add word here because we have to add the value because the segment or the circuit is in series. So to get the voltage drop, we have to add all the voltage drop for each segment, which is transformer and also cable. So we get the value total is 1.06. This is the total voltage drop. Okay, this is the exercise number 2. Okay, for 3 phase. Okay, previous example is for single phase, and this one 3 phase is for exercise. Okay, upload in individual activities in auto platform together with exercise 1 in part 1A. Okay. Okay, the question is determine the percentage of voltage drop at the MDP and at the end of the service panel for the system shown below. Okay, we have transformer here, and then we have cable, and then we have MDP here. This one is for load. Also already given the kVA, and then we have cable number 2, and we have transformer number 2, and we have cable number 3, and this one is the load for SP. Okay, this one is for 3 phase. Just to remind that for 3 phase, the RL and XL no need to times with 2, because for 3 phase the cable is in one-way connection. Okay, this is the solution for exercise number 2 that you must solve. You have to solve step number 1, to determine all impedance for 5 segment, and then step number 2, determine the load supplied for MDP and also MDP until SP. Okay, step number 3 is determine the load current magnitude and phase angle for all segment. And then put all the value of current in summary of load current in the table. Okay, next step number 4, we have to calculate the percentage of voltage drop, okay, along each segment of the circuit starting at source. Okay, final step or step number 5, student have to add the percentage voltage drop along each segment starting at the source to the point of interest. Okay, so you have to add all the 5 segment percentage of voltage drop, and the answer must be 3.37%. Okay, that's all for part 1. Okay, so we continue with part 2 in the next lecture video. Thank you.